So let's look at an idea out of Unit 1, which is determining when a function is increasing or decreasing. And we'll also talk about finding local or absolute extrema on the TI-83. Now, local and absolute extrema is just a fancy vocab word that's referring to max or min points. So when we're talking local and absolute extrema, that's just a fancy way to say that we're talking about local and absolute minimums and maximums. Okay, so let's look at an example. Let's take a function g of x, and g of x is going to be x multiplied by the quantity x plus 5 squared multiplied by the quantity x minus 3, I believe. Now, let me just consult my notebook to see if that is indeed the function that I want to be considering. Yes. Okay, so there's our g of x. So we want to graph that and find the absolute minimum and maximum points and local mins and maxes, and then determine where g of x is increasing and decreasing. So if you plot g of x in the standard window, where x and y are ranging from -10 to 10, you're going to find that we see the zeros for g of x, but we don't see any minimums or maximums. So what we got to do here, you'll see the 0 at -5, you'll see the 0 at 0, you'll see the 0 at 3. But we're going to have to adjust the y minimum and y maximum in the window so that we can see the maximum and minimum point that g of x has. So this just takes some trial and error till we get a nice window that kind of shows all the important information. So I settled on this window. I did x min. I moved the graph in a little bit. So I did x min of -7 and an x max of +7. And then I did a y min of about -110 and a y max of about 110. And that fit all the important information, and I'll do a sketch of my graph. So there's my graph of g of x, and I've labeled in the zeros there. I'll write the coordinates in, 3, 0, 0, 0, -5, 0. And now we want to find these minimum and maximum points. So in order to do that, we can use two of the options out of the calculate menu, which you can enter by hitting second and then trace. So if you hit second and then trace, it'll bring you to a menu with 7 options, and we want to be using options for minimum and maximum. So you'll see 2 options. One says minimum and one says maximum. So in this case, we're going to want to use both of them because we have one min and we actually have 2 mins here. One of the mins is -5, 0, so we don't need the calculator to find that one. We'll need the calculator to find this min, that absolute min down there. Excellent. So it doesn't matter which one you choose first. I'll detail it doing the maximum. So pick max, and then you're going to be asked for the left bound, the right bound, and a guess. So for your left bound, you have to make sure that the blinking cursor is to the left of the maximum point. So I'm just going to draw on the graph an example. So I moved my blinking cursor until it was about there. So it's definitely to the left of the max point. So it's left bound, then you have to hit enter. And then you have to pick a right bound, so that means the blinking point has to be to the right of the maximum, so I had my blinker about over there, clearly to the right of the max. You have to hit enter again. And then for the guess, you just need to move the blinker so it's close to the maximum point. So I put it right there, hit enter, and then it will display on the bottom of the screen what the maximum value is. Now make sure you write down that coordinate right away, because as soon as you hit any key, it's going to remove the maximum value coordinate from the screen. So make sure you write it down right away before you do anything else. And if you do that correctly, you should get that the max is located at negative 2.066, comma 90.098. My axis is in the way, but just right over it. Now, that is the highest point in its neighborhood. I mean, it's kind of on the tip or the top of a bump in the graph, so it's definitely a max. But it looks like my y values are heading up towards infinity on both sides of the graph, so that's not the absolutely highest point. That's just the highest point in its neighborhood. So that's a local max. Now down here at negative 5, 0, that's the lowest point in its neighborhood. It's a local min. But notice that this point over here, way down at the bottom here, that's the lowest point in its neighborhood, but it's also that point has the smallest y value on the entire graph. So that point down there, that's an absolute min. Now we're going to follow the same procedure, but we're going to choose second trace minimum, left bound, right bound, guess. We should get that absolute min is at 1.816, comma negative 99.891. So we have all of the zeros and all of the mins and maxes in a nice sketch of the graph. Now we can use the minimum and maximum values or the points rather, to talk about where the function is increasing or decreasing. So we're going to use the x values for this. So they're decreasing first. So where is the function decreasing? Now the trick to this is that you have to be moving along the graph from left to right. So as x increases, what are the y values doing? So this first part of the graph here, that I'm kind of darkening in, if you move from left to right, as x increases, y is decreasing, so the graph is decreasing on that interval. Even though it has an arrow that's pointing up, you have to read the graph from left to right. So the first decreasing part of the graph is from negative infinity until negative 5. And notice using the x values here. The second part of the graph that's decreasing is from that max point all the way down to that absolute min. That is from negative 2.066 all the way until 1.816. So those are the two portions of the graph that are decreasing. The other two parts of the graph are increasing. So it's increasing from negative 5, that min, all the way up until the max, negative 2.066. And it's also increasing from 1.816 to infinity. So I've figured out where the graph is increasing or decreasing. I could also have that increasing and decreasing information present on a number line. So I could make a number line for increasing and decreasing. So here is my increasing, decreasing number line. Now it's also referred to as a slope number line, because if a graph is increasing, it has positive slope. And if it's decreasing, it has negative slope. So instead of writing increasing, decreasing number line, that's a lot to write, you just call it a slope number line. Now on the number line, you put all of the minimum and maximum points and any discontinuities, asymptotes, holes. Well, we don't have any discontinuities here because this is a continuous polynomial function. So we'll put the min and max values on here, the x values of those coordinates. So negative 5, negative 2, 0.066, and 1.816. So there's my number line. Now, above the regions in between those values, I'm going to write a plus if the graph is increasing and a negative if the graph is decreasing. So, reading the graph from left to right, the first portion of the graph is decreasing. Then you hit that min at -5, then it starts to increase. So I'll put a plus between -5 and -2, because that's where the graph's going up. Now once I get to -2, then it starts going down again. But then once you get down to that min at 1.816, then it transitions over and starts going up again. So my number line has a minus, a plus, a minus, and a plus. That just means that the graph decreases, then increases, decreases, then increases again. So it's just kind of a visual way to describe when the function is increasing or decreasing. Just a different way to visualize this other than writing it in interval notation like I did right here. So hopefully we have a little bit better understanding of increasing and decreasing functions and how to write increasing and decreasing in interval notation and use some number lines.